right. Hello, everybody. Here we go. We are starting a new unit, new topic. We're starting physics, so here we go. All right, so we're going to describe motion first. So motion can be described when an object changes its position. So it is dependent on something we call a reference point. A reference point is an indicator that orients yourself. So it's the place where you measure, record, or witness an event. It's all about you. You use different reference points from other people. So it's totally dependent on what you see, what you measure, what you record, and what you witness. So consider the reference point when describing the motion of this car in particular. Like, it looks like it's moving, obviously, but if you were in the car, you could use a different reference point that may not seem like you're moving. We can measure motion. Distance is a lowercase d. It's how far an object has moved. It can be measured in meters, inches, feet, miles, or anything else. We can measure distance in. Displacement is delta x, which means there's a change, a distance and direction of an object's change in position. It's the difference from starting to ending point, so you're subtracting most of the time. So for example, if these runners run around a 400-meter track and end where they started, they have traveled a distance of 400 meters but have been displaced 0 meters. So let's go ahead and go over an example with this here picture. If a soccer player runs after his opponent 50 meters north, so 50 meters north, then turns around and chases him 20 meters south, what is his distance and displacement? Using this picture to the right to help you. Pictures are very important in this stuff. Highly suggest it. So we're looking for distance and displacement. So distance, first we're going to go ahead and total them together because that's what we do for distance. So 50 plus 20 gives us 70 meters. As far as displacement, you're going to subtract. So you're going to do 50 minus 20, which gives us 30 meters north. And that is your answer. All right, so another way we can measure motion, sometimes displacement isn't as easy as just kind of finding it with subtraction. Sometimes we have to use what's called the Pythagorean theorem. It's used to find the displacement. So you guys have probably seen this in math, a squared plus b squared equals c squared, where c ends up being our hypotenuse of the right triangle. It ends up being the displacement. So you are finding displacement just in a different way. Note, this will not need to be used every single time you find a displacement. It's only when it's in a triangle. So for this example, a delivery truck drives 4 miles west before turning right and driving 6 miles north to make a delivery. You're going to find the delivery truck's distance and displacement. So we're going to go ahead and write down everything we've got. So miles, or A is 4 miles, B is 6 miles, C is our delta x, so we're looking for a squared plus b squared equals c squared. So D is 4 plus 6. That gives us 10 miles for our distance. For displacement, we're going to go ahead and do 4 squared plus 6 squared equals c squared. 16 plus 36, 52 equals c squared. And then you have to take the square root. And the square root of 52 is 7.21. So that is our displacement, miles northwest. Don't forget your units and don't forget your direction when you're doing displacement. So, we're going to continue on this for these notes, but we'll have plenty of practice to go over this. So measuring motion, we're going to go ahead and do speed. So speed is a lowercase s. It's the distance an object travels per unit of time, and it can be measured in meters per second, miles per hour, feet per minute, kilometers per hour, etc. We use this equation, s is equal to d over t. So s is speed, d is distance, and t is time. So for example, suppose you ran 2 kilometers in 10 miles. With what speed did you run? So you're looking for your speed. You have your distance of 2 kilometers. Your time is 10 minutes. So you're going to use the normal equation. And S is equal to 2 divided by 10. And that gives us 0.2 kilometers per minute as our answer. For example number 4, sound travels at 343 meters per second through dry air. If a lightning bolt strikes the ground 2 kilometers away from it, how long will it take for the sound to reach you? So we're looking for time. We have our speed, which is 343 meters per second. Distance is 2 kilometers. We're going to try to change this into meters by multiplying it by 1,000. So in order to do that, we get 2,000 meters, and then we can set up our problem with distance and speed. So basically what you're going to be doing is multiplying time. No, distance divided by speed gives us time, like this. So time, you would do 2,000 divided by 343 meters per second. So that gives us our time of 5.83 seconds. Two types of speed: average speed, total distance traveled divided by total time traveled. So for example, if I were to travel to Clemson to watch the national championship football team play, it is a total distance of 300 miles from my house. If it takes me 5 hours to get there, my average speed is 60 miles an hour. Instantaneous speed is the speed at any given point and what shows up on the speedometer. So on that Clemson trip, at some point on the highway, my instantaneous speed is 70 miles per hour. At stoplights, my instantaneous speed is 0 miles per hour. So let's go ahead and talk about velocity. So velocity is just the speed of an object and the direction of its motion. So it can speed can remain constant and velocity changes if the object is changing direction. You could calculate the same as speed. You just need to include the direction in your answer if I'm looking for velocity. So velocity is still distance divided by time, just has a direction. So I'll have you go ahead and go through these practice problems real quick. Go ahead and pause, and then I will give the answers briefly. So answers for number 1, answer for number 2, answer for number 3, and answer for number 4. So let's go ahead and talk about graphing. So this is the bigger chunk of it, and we'll get lots of practice with this, but graphs can visually help us to understand an object's motion in general. So the slope or the steepness of a line, you guys have gone over this in math before, but it's calculated as rise over run, or delta y over delta x. Delta is change, so change of y over change of x. On a distance versus time graph like this one, this means that rise over run, or delta y over delta x, equals distance over time. So a distance versus time graph, the slope is actually the speed, which is kind of nice. So we can actually break down 4 different graphs to describe. So when you see a graph like this, the object is moving at a constant speed away from the reference point. And then you have distance versus time graph, where the object is moving at a constant speed coming towards the reference point. And then you have this graph here that looks like it's more curved. This object is speeding up due to the line becoming steeper. And then you have this one, the object is slowing down due to the line leveling out. Okay. And then let's go ahead and talk about these different graphs here. So this is one type of graph that you may see too. This just represents that an object is not moving at all. They may have gone a certain distance, but at the point that these data points were taken, there is no movement happening. And then you can also show movement that's variable. So at first you get your constant speed, which is this area right here that the arrow is pointing to, could be stopped like this area here that it's pointing to, and it could be speeding up like this area pointing here. So it just kind of depends on what you're graphing, but you could have your graphs look different depending on the different pieces. So we're going to go ahead and stop here. If you have any questions, let me know and I will be able to help.